Don't forget to subscribe and press the bell icon to never miss a video from testbook.com.
Hello guys, I'm Dhiraj and I welcome you all on the Testbook.com, and I'm here to provide you the best I have. So guys, once again I'm in front of you with another session on what, my dear, GATE previous year questions. So we are going to solve a lot of questions based on mechanical engineering for what, my dear, for GATE examination, right? So we are going to solve kind of previous year questions, right? Yesterday we have done one session, so today we have second part of that thermodynamics, right? So we are going to continue that part also, right? So before starting the session, what you have to do, my dear, you have to share the link of this video in a social media group so that the people will get connected and they will also get benefited of this session, right? And one more thing that you have to do, I can see that few people have already joined. So those who have joined, they have to do hit like, share and subscribe the session so that the maximum people will come and join. Okay. So this is the expectation of mine from your side. Okay. So guys, right now it's 3 p.m. So we are going to solve a lot of questions, right? So can we begin? So I think there's a time to begin now, right? So शुरू करते हैं. Okay. बिकॉज 3 बज चुके हैं एंड वी ऑलरेडी टोल्ड, मैंने लास्ट टाइम ही कहा था कि दैट वी स्टार्ट एट 3 बजे शुरू कर देंगे, राइट? सो गाइस अब शुरू करते हैं. सो गाइस सी आज का पहला क्वेश्चन आपकी स्क्रीन के ये रहा. दैट इज द फर्स्ट क्वेश्चन ऑफ टुडेस सेशन, माय डियर, एंड दिस इज द क्वेश्चन. And I already told you that please try to learn the approach, that how I approach the numerical. Approach means what? Actually मैं कैसे शुरू करता हूँ numerical, right? What they have asked, interpret the data. Data को misinterpret मत करो, अच्छे से interpret करो and decode that data as well. Sometimes we have to decode the data because the examiner play with the language, with the words, with the sentence. Okay, so guys, so here you can see, my dear, what is the question? Question says, consider the following two state of processes: heat source at 1200 Kelvin, heat source at 1200 Kelvin, losses 25 kilojoule of heat to the sink at 800 Kelvin. Okay, heat source at 800 Kelvin losses this much amount of heat to this sink which is at 500 Kelvin. Which one of the following statement is true? We have 4 statements, and out of which, my dear, 2 are correct. Sorry, 1 is correct and remaining 3 are wrong, right? So we have to identify that statement कि कौन सा correct है and कौन सा गलत है, right? So you know that I already told you that this kind of numerical has been solved by the Clausius inequality. किससे solve होंगे बच्चा? Clausius inequality से solve होंगे, right? So guys, so we'll try to solve it from Clausius inequality. That is what, my dear, cyclic integration dq by t करेंगे, right? dq by t करेंगे and जिसका भी ज्यादा आ जाएगा ये dq by t after doing this, जिसका भी ज्यादा आएगा, we'll say that that process is what, more irreversible, right now. So my dear, see, so if I talk about the case A, right? Give me a minute, my dear, huh? Give me a minute. Okay, so now see, this is, my dear, this is the case number 1, right? In the case number 1, they have said, what they have said? They said ki heat source at 1200 Kelvin loses heat to the sink at 800 Kelvin, right? So my dear, see what I'll do. I'll apply the cyclic integration del q by t, right? So it should be what, my dear? It should be equal to, that means what, qh by th, and it is loses, that means what, rejection, that is what, negative divided by what, my dear, ql divided by tl, right? So my dear, qh is how much? QH is 2500, right? So you have to put the value 25, just simply put the value, get the answer. 1200 Kelvin, hot temperature is what, 1200 minus QL, same amount of heat has been rejected, and but the temperature is 800 Kelvin. What should be the answer? कितना आ रहा है बच्चा पार्टी? I think it will come around. बच्चा पार्टी कितना आ रहा है? it will come around कितना आ रहा है? I think it's 1.04. Yes, bacha party. I hope everybody got it. That is what, my dear, 1.04 kilojoule per Kelvin. What is 1.04 kilojoule per joule per Kelvin, right? Sorry, kilojoule per Kelvin. I'm very sorry. That is its unit, and it is what, minus kilojoule per Kelvin, right? If I took the case B, my dear, similarly we'll go for case 2, that is case B. Okay, in that again we'll apply the cyclic integration of dq by t, right now. I hope everybody you're getting. Guys, if you're not getting, then please put your doubts in the comment section. Okay, my dear. And one more thing that I want to let you know, if you are new to this channel, my dear, then you can get benefited of this opportunity. There is a great exam festival and you are getting Testbook Pass just for ₹299. In addition to that, you are getting 3-month Ghana subscription, that is Ghana Plus subscription, which is free of cost for your motivation. You can listen the motivational music in that. And my dear, in the past, you are getting 100 plus courses plus 12,000 plus tests, right? And you can, if you are interested in SSC JE Mechanical Life Coaching, my dear, then you have to fill the application form, which is provided. The link of that application provided in the description of this video. And my dear, you can also attempt the Gate Reward Quiz, which is going on in the website as well as in the app, and you have a chance to win exciting prizes for that, right? So guys, get benefit of these opportunities and offer which has been given to you by the textbook. Okay, so this is, now we come to the numerical, my dear. Now we come to the numerical. Okay, we come to the numerical. So my dear, case 2, cyclic integration dq by t, right? Now listen to me. Again we'll do the same thing, that is what, qh upon th minus ql upon tl, right? So here the higher heat is how much? That is what, 2000 kilojoule. Okay, it is what, 2000. Highest temperature, that is what, my dear, 800 Kelvin and 800. And the same heat is rejected at sink, which is having temperature 500. So it should be what, bacha? 2000. It should become around minus 1.5. It comes around what, bacha party? Very good. वाइजैक का कट ऑफ कितना है? वाइजैक का कट ऑफ आपको बता दिया गया है कि it should be in the range of 150 to 155, right? I hope you got it, bacha party. So my dear, here you are getting minus 1.5 kilojoule per Kelvin. So my dear, you can see that there is dq by dt, there is nothing more entropy. Entropy in the process 2, that is in case 2, is more, right? So we can say that process 2 is more irreversible than process 1, right? Number 2 is correct. Yes, bacha party, I hope you got it. Yes, number 2 is correct. Okay, so here we go. We go for the next. See. Okay, there's another question, that is a monoatomic ideal gas, having gamma given, molecular weight of that gas is also given, that is 40. Okay, is compressed adiabatically compressed किया हुआ है, and that is from 0.1 megapascal 300 Kelvin into 0.2 megapascal. Okay, the universal gas constant is 8.314 kilojoule per mole per Kelvin. Kilojoule per mole per Kelvin, kg mole per Kelvin. Okay, the work of compression of the gas in kilojoule per kg. You know that it is what, my dear? It is what? Adiabatic process. So you know that it is nothing but formula, work done, that is P1 V1 minus P2 V2 divided by gamma minus 1, right? Right, bacha party. This is the formula for calculating work done in an adiabatic process, right? But I can replace this by MRT1 as its ideal gas. It should be what? MRT2 divided by gamma minus 1. Am I right? So my dear, yes or no, bacha party? Yes, but they have said you have to calculate kilojoule per kg. So my dear, I'll took the value of m equal to 1. So what I'll get RT1 minus T2 divided by gamma minus 1. right? So my dear, what I'll get? R का वैल्यू क्या होगा? R का वैल्यू होगा 8.314 divided by 40 multiplied by T1. T1 is how much? T1 is how much? We know that T1, but we don't know T2, right? T1 minus T2 divided by gamma minus 1. That is what, my dear? 0.4. But before that, you have to calculate. It is adiabatic process, so you can write T2 by T1 is equal to what, bacha? P2 by P1 raised to power gamma minus 1 upon gamma. Am I right? I hope everybody is getting. You can write T2 by T1 is equal to what, my dear? P2 by P1 raised to power gamma minus 1 upon gamma. This is a formula, right? Now, my dear, listen to me. If you done this, then, my dear, you'll get T2 directly because you know P2 by P1. T1 is this much and P2 is how much, bacha? 0.2 divided by 0.1. 0.2 divided by 0.1 raised to power gamma minus 1, that is 0.4 divided by 1.4, right? Yes or no? Of course it is. Of course it is, right? Sorry, it's 1.67 now. It's 1.67. It's so it should be 0.67 divided by 1.67. From here you will get T2. And my dear, T2 will come around. Kitna aa raha hai T2? Your T2 will be, my dear, in the range of, that is 396.18. 396.18 आएगा बच्चा. It is how much? 396.18 Kelvin. You got T2. Now we will come back to this work done, and that will be what, my dear? RT1, that is 8.314 divided by 40 multiplied by what, बच्चा? किसको करेंगे आप? Yes, what is the value of T1? T1 is how much? T1 is 300. T1 is how much, bacha? T1 is 300 now. Wait. T1 is 300. T1 is 300, right? Now T2 we got it. Okay. I hope we got it, bacha party. Right? So we got T2 as well. T2 is what? 396. So it is what? 300 minus 396.18 divided by what, bacha? Gamma minus 1. That is 1.67 minus 1. From here you will get the W, and your W will come around by, my dear, kitna aega? 29.7. It should be minus. Kitna aega? 29.7. It is how much? It is 29.7 kilojoule per kg. Why it is negative? Some people thought it is negative, so their answer will be wrong. No, my dear, it is negative because it is a work input. So you can say W input like this, and you can write only to 29.7 kilojoule per kg, right? I hope everybody got it. I hope everybody got it. Yes. Okay, guys. I hope you got it. Right, bacha party? Okay. So if you got this point, my dear, then we'll go ahead. आगे चलते हैं अभी फिर. Okay. Next question. See. If you have any doubts regarding this questions, please tell me. The content of well-insulated tank are heated by a resistor of 23 ohm in which 10 ampere current is flowing. Okay. Consider the tank along with its contents as thermodynamic system. The work done by the system and heat transfer to the system are positive. Okay. The rate of heat, work and change in internal energy during the process in kilowatt hour. Kya? That we have to calculate. Okay. वो हमें calculate करनी है. So my dear, how we can calculate? कैसे calculate करेंगे? So I want to let you know, my dear, see कि यहाँ पे contains well insulated. It is what? It is well insulated. You can see this word. Well insulated. That means what, my dear? dq is equal to what? 0. dq 0 are heated by resistor. So my dear, you know that whatever the amount of heat that will be dissipate, that will contribute into the internal energy. वो क्या बढ़ाने की कोशिश करेगी? जो भी heat dissipation होगा during that will be count for or will be utilized for what, my dear? An increment of what? Internal energy, right? Very good. So my dear, see, and that heat will be that means what, my dear? Delta U is nothing but what? I square into R. So my dear, I square into R, that will be nothing but बच्चा पार्टी क्या आएगा? That will be what? 10 raised to power 2 into 1023. है ना? Yes or no? Of course it should be, right? So here I can write, my dear, what? This 10 ohm now, I square 10 ampere, that is what? 10 square into 2.3. That means what, my dear? It is what? 23, not 2.3. It is 23. So my dear, it will become what? 2.3 kilowatt. Yes or no? Of course, it should be what, my dear? I have simply converted watt into kilowatt, right? I hope everybody got it. Okay. So my dear, see. Now I have tell you, you know that first law of thermodynamics. That is what? So my dear, you know that this du will be what? This is 0. This is what? 2.3 plus del W, right? So my dear, can I say del W is equal to minus 2.3 kilowatt? It is what, my dear? Q is equal to 0, right? This is equal to plus 2.3, right? It's correct. Number 1, right? Option number 1 is correct. I hope everybody got it. I hope everybody got it. Here I go for next point. Chale aage. Can I go ahead? I hope everybody got it. Bacha party. Okay. So here I an experimental setup. Air flows between station P and Q adiabatically. Okay. The direction of flow depends on pressure and temperature. जो डायरेक्शन है फ्लो करने का वो डिपेंड कर रहा है प्रेशर पे और टेम्परेचर पे. ओके. मेंटेन एट पी एंड क्यू. कंडीशन मेंटेन एट पी एंड क्यू. द कंडीशन at station P are 150 kilopascal and 350 kilopascal. 350 Kelvin, sorry. The temperature at station Q is 300 Kelvin. The following are the properties and relation pertaining to the air. Specific heat at constant pressure Cp is equal to 1.005 kilojoule per kg Kelvin. Okay. Specific heat at constant volume is also given. Characteristic gas constant, that is all, is also given. Enthalpy is given, and internal energy is also given, right? Now the question is, what is that question? Question is this one. If the pressure at station Q is 50 kilopascal, the change in entropy of SQ minus SP in kilojoule per kg. My dear, you have to find out the change in entropy, that is what, from Q to P. From Q to P के बीच में what should be the entropy change, that you have to calculate, my dear. That you have to calculate. So how you calculate? It's very easy to calculate, right? So what is formula? Cp ln T2 by T1 minus R ln P2 by P1, right? So you can write, my dear, you can directly write formula SQ minus SP. You know that, my dear. It is what? Cp ln T2. T2 means what? TQ. T2 means what, bacha? Here T2 means TQ divided by TP minus R ln P2. P2 means what? PP. Sorry, PQ divided by PP. Right? I hope you got it, bacha party. Very good. So if you got this thing, my dear, I'll simply put the value, that is what? 1.005 ln of TQ. TQ is how much? We have to check it out. So you can say this, my dear. Flow direction of, okay, condition P and Q. Okay. The condition at station P is this one. Okay. And Q is 300 Kelvin. Okay. 300 and 350, right? 300 and 350. Okay. It is what, my dear? 350 and 300 minus R. R means what, bacha? 0.287 and PQ. PQ again, my dear, you have to calculate, I think. Calculate करना है PPT? No, it's given 50 kilopascal. कितना given है? 50 kilopascal it is given. You can check it out. My dear, here. It is PP what should be the pressure, so that we have to calculate my dear, वो हमें calculate करना पड़ेगा, right? So how we can calculate my dear, कैसे calculate करेंगे इसको? Yes, anybody of you? It is not given, right? Oh, given ना 50 kilopascal given है. Pressure, last line they have mentioned, see my dear here, यहाँ पे जो देखा था हमने, let here they have mentioned PQ, right? So PQ is 50. PP is what my dear? PP कितना है? PP is your nothing but, yes बचा पार्टी, it is 150. Very good, it is 150. Now my dear, if you calculate it, you will get this SQ minus SP, and that will come around, कितना आएगा बच्चा वो? 0.160. 0.160 kilojoule per kg Kelvin. Number 3. I hope it's clear to you. Okay, so guys, now we'll go ahead. If air has to flow from P station to Q, the maximum possible value of pressure in kilopascal at station Q close to, what my dear, air has to flow from P to Q. P से Q flow करना चाह रही है, so what should be the maximum pressure in kilopascal at station Q? Q में क्या pressure होगा? Okay, Q में what should be the pressure, that we have to identify, right? बच्चा पार्टी, yes or no? Of course. So see my dear, I can easily find out. I can easily find out. It is what? Adiabatic, right? So can I say like my dear, TQ by TP is what my dear? PQ by PP raised to power gamma minus 1 upon gamma. Gamma minus 1 upon gamma कर दिया. My dear, here I'll get TQ upon TP raised to power gamma upon gamma minus 1 is equal to PQ upon PP. Right? Bacha party? I hope you got it. If you got it, my dear, then I want to let you know. Then you can simply put the value and you can get the answer, right? And gamma you can took 1.4. Gamma you can took, my dear, 1.4, right? So here what I'll get? TQ is given. TQ is 350, I think. It is 300, right? My dear, it should be what? It should be what? 1.4 divided by 0.4, right? My dear, here PQ, we have to identify PP is given. PP is what, my dear? PP is how much? Let me check. PP is what? 150 kilopascal. It is what, my dear? It is 150 kilopascal. So from here you'll get PQ, and that PQ will come around, bacha. That PQ will come around 87.45. 87.45 kilopascal. I hope everybody got it, right? So my dear, now I'll go for next. I hope this diagram is visible to all of you. I hope this diagram is visible to all of you. Bacha party? Yes, I hope everybody have visibility of the diagram. Okay. So guys, here I go. Okay, चलते हैं आगे. What they say, the temperature and pressure of air in a large reservoir are 400 Kelvin and 3 bar. Okay. A converging diverging nozzle of exit area 0.005 meter square is fitted to the wall of the reservoir as shown in the figure. Okay. The specific pressure of air at exit of section for isentropic flow through a nozzle is 50 kilopascal. Okay. The characteristic gas constants and ratio of specific heat of air are 0.287 kilojoule per kg Kelvin and 1.4 respectively. Okay. So we have to identify, my dear, the characteristic gas constant is given. Okay. Now, my dear, the question begins from here. The density of air in kg per meter cube at nozzle exit. Nozzle के exit में क्या होगा? That is velocity. Sorry, density. Density we have to find out. Density we have to find out. Yes. So at exit, my dear, that means what? See, I'll tell you. this PV is equal to MRT, you know that, right? So my dear, can I say P is equal to M by V RT, that is nothing but rho RT. My dear, that means rho is nothing but P by RT, right? P by RT is there, right? If P by RT is there, my dear, now see, but I want to calculate rho at exit, that is rho 2. So it should be what, my dear? P2 upon RT2, right? So my dear, you know that they have given each and every data, but they have, see, large 400 Kelvin there. Okay, 3 bar respectively, converging diverging nozzle area is this much. Okay, fitted to the wall reservoir as shown in the figure, right? So my dear, it is what, adiabatically, right? So my dear, I can write T2 by T1 is equal to P2 by P1 raised to power gamma minus 1 upon gamma. Right now, I hope you got it. So my dear, from here I'll get T2 is equal to, my dear, what? T1. So T1 is how much? Yes, bacha party. T1 is how much? So T1 is nothing but, kitna hai bacha? 400. Kitna? 400. Very good. So T1, P2 is what? 50. कितना है P2? P2 is 50 and P1 is 300. Gamma minus 1, that is what, my dear? 0.4 divided by 1.4. So from here you are going to get T2. And my dear, T2 क्या बचेगा बच्चा? T2 क्या बचेगा? T2 will be 239.5. कितना? 239.5 Kelvin. I hope you got it. Bacha party. Now they have, but I want to calculate kitna? I have to calculate rho 2, right? I have to calculate rho 2 now. So see, my dear. So rho 2 will be P2. P2 is what? P2 is what, my dear? 50. P2 is how much? P2 is 50 now. 50. Right. Very good. Divided by 239.5 plus क्या होगा बच्चा पार्टी? RT 0.287, right now? Yes or no? It is what, my dear? 0.287. कितना हो जाएगा? It is 0.287. From here you'll get rho 2 and that will come around, bachcha party, that will come around 0.727. 0.727. 0.727 kg per meter cube. I hope everybody got it. I hope everybody of you got it, right, bacha party? You got rho 2 now. That is density at the exit of nozzle, right? And this should be equal to 0.727 kg per meter cube. We have done nothing special. We have simply utilized the fundas we have. That's it. Okay. I hope you got it, bacha party. Now I'll go ahead. The mass flow rate of air through the nozzle in kg per second. Mass flow rate. Same question. जो क्वेश्चन पूछा था उसी क्वेश्चन में कंटिन्यू करके क्वेश्चन पूछा है. मास फ्लो रेट ऑफ द एयर in kg per second. Mass flow rate of air in kg per second, my dear. Right? So you know that. Right? अब आपको क्या पूछा है? मास फ्लो रेट पूछ लिया. कहां पूछ लिया? वही मास फ्लो रेट थ्रू द नोजल पूछ लिया, राइट? So my dear, you know that mass flow rate is nothing but what? Rho AV. Mass flow rate is nothing but what? Rho AV, right? Density into area into volume, right? My dear, and this will be what V2 supposed to be. So my dear, how I can find out V2? V2 is nothing but velocity, right? So my dear, you know that it is what? Nozzle. So V2 is nothing but what, my dear? 2000, right? And it should be what? H1 minus H2 under root, right? This is the formula for us. Right now, steady flow energy equation, धुआं सा याद आ रहा है कुछ? If you are able to recall, my dear, धुआं सा. It is nothing but what, bacha? It is nothing but steady flow energy equation. We have derived this, and it is when we apply the steady flow energy equation to the nozzle, we get this equation, right? So my dear, it is 2000. What is H1? H1 is how much? H1 is how much? Yes, Bacha Party. So H1 I can write. H1 I can write, my dear. H1 को मैं लिख दूंगा CPT1 minus CPT2, right? But you know that you don't know T2. So you can write it is adiabatic process. So T2 by T1 is equal to P2 by P1 raised to power gamma minus 1 upon gamma. That means, my dear, T2 is equal to what? T1 into P2 raised to power gamma minus 1 upon gamma, right? So now, my dear, how we can solve? अब कैसे solve करेंगे इसको? So I have to tell you, see. You get T2 first. T2 मिल जाएगा आपको, right? And that is what? T2 is what, my dear? Had you got T2? Wait, क्या पूछा है क्वेश्चन में? Let me check the question again. Mass flow rate. Okay, so mass flow rate we can easily calculate now, right? Because right now we get T2 is equal to what, my dear? T1 into P2 by P1 raised to power gamma minus 1 gamma, right? Bacha party. So see what I'll do now. We got this. I already got, my dear, T2 is nothing but कितना मिला T2 मुझे? T2 I got it. T2 you got it, my dear. You'll get each and everything, right? So just try to understand. T1 P2 by P1 raised to power gamma minus 1 upon gamma. So my dear, from here you'll get T2. Put the value of T1. You'll get T2, and we already solved this 239.5 Kelvin. Right, Pacha? I hope you got it. Now, my dear, now listen to me. If you got this one, my dear, you can easily calculate V2. Right? If you calculate V2, just multiply it by what, my dear? Rho AB. Right now, A is given, rho is also given. So, my dear, see, you'll get V2. V2 is nothing but 2000 into what, my dear? 1.005. Kitna? 1.005. And it is T2. That is what? And T1 what, my dear? T1 कितना है बच्चा? T1 कितना है? It is, sorry, T1 हमारा 400 था. I'm very sorry. मैंने उल्टा लिख दिया. That is our T1 is 400 minus 239.5, right? So from here you'll get, my dear, V2. And your V2 come around कितना आ रहा है बच्चा? V2 567.98. It is 567.98 meter per second, right? Okay, so if you got V2 now, my dear, you can easily calculate what? Rho A V2. So rho, you know that rho is given, and rho is how much? कितना है बच्चा? 0.727. कितना है? 0.727. We have already calculated rho. Rho हमने अभी already calculate करा है क्वेश्चन नंबर 1 में, my dear. We have already calculated rho, and rho comes around 0.727 into what, my dear? 0.005 V2. Let me check. V2 is how much? 567.98. So from here you'll get, my dear, mass flow rate, and that will come around कितना आ रहा है बच्चा? वो आपका आ जाएगा 2.06. It is your mass flow rate, right? I hope everybody got it. I hope all of you got it, this thing also. I hope everybody got it, this thing, that here they have asked that how calculate the mass flow rate. So my dear, simply you know that we have, see, the only thing that you have to keep in mind, यहाँ पे twist thing था, that what, my dear, you have to find T2, and you have to write that velocity, that is enthalpy, in terms of temperatures and specific heat, and that what I have done over here, right? Nothing special I have done. कुछ भी नया नहीं था यहाँ. Okay. Another question. See, air enters an adiabatic nozzle at 300 kilopascal. Okay. And 500 Kelvin with a velocity 10 meter per second. Velocity is how much? 10 meter per second. Okay. It leaves the nozzle at 100 kilopascal, velocity 1 meter per second. Inlet area is this much. Specific heat of air is what, my dear? 1008 joule per kg Kelvin. Okay, the exit temperature of the air. We have to calculate exit temperature of the air. How we can calculate exit temperature of the this one? Yes, anybody? Yes, bacha party. So I want to you directly apply what, my dear? Steady flow energy equation. So what you will get? H1 plus V1 square by 2 plus GZ1, that is potential energy has been neglected, is equal to Q, is equal to S2 plus V2 square by 2. I directly neglect what, my dear? Potential energy. So it should be W, right? Bacha party, yes or no? Right now, adiabatic nozzle guzar jayega, right? And in nozzle there is no work transfer, right, my dear? So what I'll get? I'll get, my dear, H1 minus H2 will be what? I will get H1 minus H2. H1 minus H2 is nothing but what, bacha? It is V2 square minus V1 square by 2. Right? Yes or no? Of course it should be. So my dear, see what I can do. I can write Cp T1 minus T2 is equal to V2 square minus V1 square by 2. Right? Here I go for next page. So my dear, you know that 1.005 T1 is given. T1 is how much? T1 is how much? T1 is given, that is 500, bacha. It is 500 and Cp is 1008. I have written how much? 1005. It's not, it's 1008 in the question. You can check it out. It's 1008, right? So I can write 1008, and my dear, temperature is what? Temperature is what? It is 500. How much? Kitna bacha? It is 500. It is 500 minus T2 is equal to what, my dear? 180 square minus 10 square divided by 2. So from here you will get T2, and my dear, your T2 will come around 484 Kelvin. Kitna aega bacha? It will be around 484 Kelvin. Okay, I hope you got it. Yes, bacha party, I hope you got it. It will come around 484. Kitna aega bacha? 484 aega answer, right? I hope everybody got it. Guys, please reply. Those who are watching, please let me know and be fast. Haji bacha party. Okay, so here we go for next. Pressure, temperature and velocity of air flowing in pipe 5 bar, 500 Kelvin, 50 meter per second respectively. The specific heat of air at constant pressure and constant volume are this much, okay, and 0.718 kilojoule per kg Kelvin respectively. Neglect the potential energy if the pressure and temperature of the surrounding are 1 bar and 300 Kelvin respectively. The available energy in kilojoule per kg of air stream is pressure and temperature of velocity flowing through the, it is given, that is they have given initial pressure, temperature and velocity V1. Specific heat of air at constant pressure, constant volume, they have already given. Potential energy we have to neglect. Pressure and temperature of the surrounding 1 bar 300 Kelvin. Available energy in kilojoule per kg. We have to calculate AE, available energy, right? And you know the meaning of available energy, right? Now how we are going to calculate? Yes, my dear. Anybody? Yes. Yes, bacha party. How we can calculate? It should be what? CPLN, right? T1 by T0, right now? Surrounding. Okay. So see, my dear. So first of all, we have to write the equation for available energy. Right, bacha? Yes or no? Okay. So here I can write, my dear. C. Available energy in terms of what? In reference to the surrounding and the system, my dear. It should be what? H1 minus H0. H0 is nothing but enthalpy of what, my dear? Surrounding minus T0 into what, my dear? S1 minus S0 plus what bacha, v1 square by 2 minus v naught square by 2, right? Yes or no? Yes or no? V naught is nothing but velocity of surrounding. I hope you got it. Okay, so my dear, you can see here that there is s1 minus s naught, right? So first of all we should calculate s1 minus s naught, right? So it should be what, my dear? sp ln of t1 by t naught minus r ln of p1 by p naught. P naught is pressure of surrounding, right bacha? It is what, cp is nothing but kitna aayega beta, 1.005. Higher na? Of course it should be. Of course it should be, right? So here I go ahead. 1.005 ln of T1 is given, but T1 kitna given hai? 500. T naught, that is surrounding temperature, 300. You have to simply put the value, get the answer. That's it. Nothing you have to do in this kind of questions, my dear. And it should be 0.287 ln of. People thought ki yaar previous year it's very easy. The numerical will be not like this. Numerical will be like this only. It is based on this only. So that's why I said if you practice more, definitely you will get concept more. P1. P1 is how much? 5 bar. Okay. And P naught, that is 5 bar. Right, my dear? So from here you will get S1 minus S naught. And it will come around. Kitna aa raha hai bacha wo? It will come around 0.05147. Right? 0.05147 kilojoule per kg Kelvin. Right, bacha party? I hope you got it. Right now? So my dear, if you get this one, now I'll calculate this one, right? AE. So my AE equation will become what, my dear? H1 minus H naught is there. So I will write in terms of CPT1 and CPT naught, right? So I have taken CPT1 minus T naught, right? And what, my dear? Minus T naught into S1 minus S naught we have calculated, right? And plus what, my dear? V1 square by 2 minus V naught square by 2. Right now? So CP, that is what, 1.005. T1 is what, my dear? T1 is 500 now. T1 is 500 Kelvin, right? And T naught 300. Very good. So here I can write 500 minus 300 minus T naught 300. S1 minus S naught we have already calculated, and this is 0.05147, right? It is 0.05147. Nothing. It's quite lengthy. Lengthy means lamba and numerical, nothing more than that in it, right? So plus now velocity is given right now, and my dear, surrounding velocity will be what? Neglected. So that's why it will be get 0. It will going to be neglected, so it will be get 0, right? And V1 is given already. V1 in the question they have given, and that is what, 50 meter per second, right? So I'll put the value 50 square by 2. Okay. Yes, but please tell me, is it clear now? And one more thing that you have to do. Here it is in meter per second, but it is in kilojoule per kg. So what you have to do? You have to just multiply it by 1000. So it will become in kilojoule also. My dear, now you'll get, if you do the calculation, my dear, you will get the answer that is around 186.8. Unit will be kilojoule per kg. Now, my dear, what should be the option? Option kaun sa ho jayega? This one. Number 2 will be correct. Number 2 will be correct. I hope everybody got it. Yes, guys, those who are watching, please let me know and be fast. Okay? So this is all about what, my dear? This is all about the available energy. And this numerical is quite very useful. Okay? ऐसा numerical साथ सकते हैं exam में. Okay? Now, my dear, see, it's a very good question. Two identical metals are there. Okay? Block L and M. Okay? Their specific heat are given. Okay? Each having mass of 5 kg. दोनों का मास क्या है? 5 kg है. Are initially at 313 Kelvin, and their initial temperature is quite 313. दोनों का. A reversible refrigerator extracts heat from block L, okay, and rejects heat to the block M until the temperature of block L reaches 293. Okay. The final temperature in Kelvin of block M. Block M का temperature क्या होगा? They are asking, right? So बच्चा party, before beginning the numerical, what you will do? You have to what? You have to draw the block diagram so that it is easy to get each and everything, right? So my dear, see, I'll draw. This is your block L, sorry M, and this is your block L, right? And in between them there is a what? Reversible refrigerator, right now? Right? So my dear C, this is your block L, this is your block M. Heat is extract, the refrigerator extracts heat from where? From where? From L, and it will reject that heat at what, my dear? Qm. So definitely the temperature of this T1, and it is initial temperature T1. It is going to change Tf, and it is going to change from T1 to T2. Right? I hope everybody got this point now. Everybody got this point now, right, bacha party? So here I go ahead. So my dear, it is extracting how much heat? Q1, and it is rejecting heat Q2, right? Are Hayana, very good. My dear, see now. Try to understand each and everything. What should be the entropy change of block L and M? Kya hoga bacha party? Yes, anybody? So my dear, see. What should be the entropy change? So it should be none other than, if I talk about entropy change of block L, what it should be? क्या होगा बच्चा? It should be delta SL. It should be what, my dear? MC ln of what it should be? It should be T2 by T1. Similarly, for delta S of M block, it should be again MC ln of what, my dear? T2. That is what it should be, TF. TF by T1. Right? And you know that delta S of universe is nothing but what, bacha? Delta S of system plus surrounding. Delta S of system plus surrounding, yes or no? Of course it is. Right? But here, my dear, I want to tell you, delta S of universe for this refrigerator is going to be 0 because it is reversible. Right? So, my dear, what I can write? I can write MC ln T2 by T1 plus MC ln TF by T1 is equal to 0. Right now, दोनों को ऐड कर दिया इसमें. Okay. So my dear, what I'll get MC ln common. MC is common, so ln should be what? It is product rule लग जाएगा यहाँ पे. So what I'll get? T2 TF by T1 square. Right? It should be equal to 0. So my dear, I'll get what? MC इधर जाएगा 0 हो जाएगा. So what I'll get finally T2 TF by T1 square. Ln of 0 means what? E raised to power 0, and that should be equal to 1. So my dear, what I'm getting? We have to find out TF now. So TF will be what, bacha? T1 square by T2. So T1 is how much? I have to calculate TF. So my dear, T1 square. T1 is how much? Let me check. T1 initially 313, right now. So here that is 313 square divided by T2, and T2 is how much? 293. कितना बचा? 293. Now you calculate TF. So my dear, your TF will be around, कितना आ रहा है बच्चा TF? TF is how much? It is 334.6. It is what, बच्चा? It is 334.36 Kelvin, and this will be your answer. यही आपका आंसर. I hope everybody got it. This will be your final answer. And my dear, I want to tell you कि ये जो आपका जो ऑप्शन होगा, that option will be what, my dear? Let me check. यहाँ पे ऑप्शन दिया नहीं था, but this will be your answer. Correct answer will be 334.36 Kelvin. Anybody have any kind of a doubt? Please let me know, my dear. Be fast. Okay. थोड़ा सा जल्दी करेंगे. चलें आगे. बच्चा पार्टी. Here we go for next. A closed system contains 10 kg of saturated liquid ammonia at 10 degrees centigrade. Okay. Heat addition required to convert the entire liquid into saturated vapor. Entire liquid to saturated vapor. That is phase change. Okay. Vapor at constant pressure is 16.2 megajoule. If the entropy of the saturated liquid is this much. Okay. And entropy of saturated vapor will be vapor, that, my dear, you know that total amount of heat that you have added, it should be what? Mass multiplied by the what? The amount of heat addition you require to change the liquid into vapor, so it should be HFG, you know that, right now. So it is how much, bacha? It is how much? It is 16.2 is equal to what, my dear? 10 into, because they have 10 and it should be what? HFG 16.2 megajoule. So इसको कर लेंगे हम लोग किलो जूल पर केजी में. So it should be what? 10 raised to power 3 ना. So it should be what? 1.62 into 10 raised to power 3. क्या होगी बच्चा ये? हाँ जी बच्चा, बी फास्ट. इट शुड बी व्हाट? कितना, क्या हो जाएगी ये? यस बच्चा पार्टी, इट शुड बी व्हाट? इट शुड बी none other than 1.62 into 10 raised to power 3 kilojoule per kg. You got heat. Now you have heat, my dear. Now you can calculate. Now you can calculate what? Entropy, right? अरे हाँ या ना बच्चा पार्टी? Yes, of course you can calculate entropy. So my dear, how you can calculate? कैसे करेंगे? So see my dear, I can calculate ER Raja Patel 162. Very good dear. No, it should be 1.62. 10 कट जाएगा. So it should be what? 1.62 into 10 raised to power 3 kilojoule per kg. And my dear, now I can calculate SFG. SFG is nothing but what? dq by t. That is what? HFG divided by t. So HFG is what, my dear? 1.62 into 10 raised to power 3 divided by temperature. Temperature is what, my dear? 10. That means 273 add करेंगे. So it should be 283. So my dear, what you are getting? SFG will become कितना आएगा? तन्मय सोनी, yes, I am going, my dear. No issue. So what should be अभी क्या होगा यहाँ पे? What is our entropy? That entropy should be 5.7244, right? कितना आ रहा है ये आ रहा है आपका 5.7244 किलो जूल पर केजी केल्विन, राइट ना. ये इतना आ गया SFG. ओके, नाउ माय डियर, यू नो दैट SFG को हम लोग क्या लिखते हैं? वी राइट लाइक दिस SG minus SF, राइट. सो इन द नेक्स्ट स्लाइड, SFG, you know that it is 5.7244. SG we have to find out, that is vapor. SF is given and it is what? 0.88, right? So I'll put that value 0.88. My dear, from here I'll get SG, and SG कितना आएगा बच्चा? Okay, I'll answer engineering club that I already told you beta कि कितना जाएगा, right? I already told you that 170 marks at least you required, 170 180 marks you required in each paper, my dear. I'm talking about each paper. So what should be the answer now? It should be 6.604 kilojoule per kg Kelvin. And this will be your final answer. And this is nothing but what, my dear? This is nothing but entropy of saturated vapor. Okay? This is entropy of saturated vapor. Okay, bacha party? I hope you got it. Okay? Yes, everybody got it? हाँ जी बच्चा, सबको समझ आई चीजें? Okay, that's great. See, this kind of numerical, see, आपको लग रहा होगा कि यार numerical इतना लंबा है, ऐसा आएगा नहीं आएगा, कुछ और आएगा. I want to tell you, see, if you do the practice, you know, in this each and every question is kind of variety question in the previous year, right? So once you go through all the papers, you know, don't solve the paper topic wise solve करोगे तो क्या होगा बच्चा उसमें, that your read conduction, read आपने read करा open closed system and basics of thermodynamics, you have solved the question, that will be easily done. But my dear, when you solve combined subject, so at that time you have to jump from entropy to first laws to again you come to the pure substance to again entropy, exergy, available energy. So in this way, no, आप used to हो जाते, and when you become used to of this kind of thing, my dear, that will get benefited at the time of attempting the actual paper of a GATE examination. जब आप गेज का एक्चुअल पेपर एग्जाम करोगे ना, तो वहां पे कोई टॉपिक वाइज नहीं है, मिक्स है, यू नो दैट, आपको सबको पता है. सो दैट्स व्हाई आई सेड इट्स इज बेटर दैट यू शुड अटेम्प्ट द क्वेश्चन रैंडमली अटेम्प्ट करें कोई भी प्रीवियस ईयर क्वेश्चन. ओके, सो दैट विल बी मोर बेनिफिशियल. Hello, most welcome, Rajwant. Rajwant, you're most welcome, dear. Okay. So guys, this is, we'll go for the next question. Okay, एक बाद एक और क्वेश्चन लेते हैं. An amount of 100 kilowatt of heat is transferred through a wall in a steady. Okay, one side of wall is maintained at 127, another is 27. The heat generated, heat transfer हो रहा है. You have to tell me. I already told you that it is based on what? Thermodynamics, and that concept that I already told you regarding the engine, if you remember, right? So my dear, entropy generation will be what? Entropy generation will be what, my dear? Use of simply S2 minus S1. Whatever the difference between these 2 points, that will be what? Entropy generation. So S2 will be what? S2 is what, my dear? The 100 kilowatt. Right now? Arey bacha party, bolo. It is what, my dear? Sorry, it is 100. Right? Kilowatt है, watt में कर लेंगे, so it should be what? 10 raised to power 3 divided by what बच्चा? S2, that is 27, that is 300, minus again 10 raised to power 5, what, my dear? 1 upon 273, that is 300, 400, right now? So what you are getting? कितना आ रहा है बच्चा ये? Easily you can do it, easily. It's very easy question, and this kind of question has been already asked in the examination. So what is the answer for it? It should be what, my dear? 83.33. कितना आ रहा है? 83.33. You can do it, but simply answer. It's very simple. That you have to just final minus initial karna tha, you'll get answer. And it is of how many marks? 1 marks in the gate examination, and 1 marks matters a lot in a gate. 1 marks matters a lot in a gate examination. Okay, bacha party. So here I go for next. And this is the last question. Okay, this will be the last. No, don't worry. This will be the last question. Certain amount of an ideal gas initially at pressure T1, temperature T1. First, it undergoes a constant pressure process, that is 1, 2, such that T2 is equal to 3 thrice T1 by 4. Okay. It undergoes a constant volume process 2, 3, such that T3 is equal to this much. The ratio of final volume to the initial volume of the ideal gas. They are simply that you have to done in this question. You have to simply do what, my dear? You require rearrangement. If you do the rearrangement, you'll get each and everything. आपको सब पता चल जाएगा. Okay. So my dear, can we go ahead? चलें आगे. So here we go. So first of all, we are going to talk about process 1, 2, then 2, 3. Okay. We'll talk about the process 1, 2 and 2, 3. So if I talk about process 1, 2, right? See, my dear, because I have to identify what was final volume. That is, I have to identify V3 now. मेरे को V3 find out करना. So process 1, 2. That is what, my dear? Process 1, 2, constant pressure process, right? P is equal to C. That is P1 is equal to P2 is there in this process, right? So if it is so that, my dear, I can write. Can I write like this? That is what, my dear? V1 by V2 is equal to T1 by T2, right? Or I can write this kind of thing. That is, can I write like this? V2 by V1 is equal to what, bacha? T2 by T1, right? So my dear, you know that T2 is what? Thrice T1 by 4. So it should be what, my dear? Thrice T1, T1. It will get cancelled. My dear, you are getting V2 by V1 is equal to this, right? Similarly, my dear, if I go for process 2, 3, and this is nothing but process 2, 3, in that what they have done? Constant volume. In this, V2 is equal to V3. If it is so, my dear, is V2 is equal to V3, what I can write? I can write V3 by V2 is equal to what, my dear? V3 by V2. That means V3 by V2 will be 1, right? My dear, I can write V3 by V2. क्या लिख सकते हैं इसको? In terms of 1 and 2. I can write V3 by V2 multiplied by V2 by V1. I can write V3 by V2 multiplied by V2 by V1. Sorry, I have done mistake, I think. It is V3 by V2 multiplied by what, my dear? V2 by V1, right now. So just wait. I have done mistake over here. That is, I can write V3 by V1 is equal to what, my dear? V3 by V2 multiplied by V2 by V1. See, my dear. V2 will cancel, you'll get V3 by V1, right? So, my dear, see, V3 by V2, already you got 1 right now. This value is 1. So 1 multiplied by V2 by V1, how much you got? 3 by 4. Right now, so its value is 3 by 4. So my dear, V3 will be what? V3 will be 3 by 4th of V1. Right now, the ratio of the final volume, okay, to the initial volume. That means V3 by V1. That should be what, my dear? 3 by 4. That is what? 0.75, I think. Number 2. Am I right? It is what, my dear? Number 2 is correct. 0.75. Correct, Bacha Party? Okay. I hope you got it, Bacha Party. Okay. So here we stop, my dear. Okay. यहाँ पे रुकेंगे. And we'll solve the next part. We'll solve the numericals and we'll solve theory questions. No, till now we have finished the papers, that is questions belong to the 2014. Now we are moving to the in the next session, that is from up to 2017, and then, my dear, we'll finish in the next session. Those session mein we'll finish the previous year question of thermodynamics, and then we'll start, my dear, applied thermodynamics. Okay, so that will be better. That will be better, Bacha Party. Okay. So I think it's enough for today. So guys, we'll see you in the next session then. Okay? We'll see you in the next session. Next session में मिलेंगे आपसे. So guys, take care. Bye bye. Shabba khair. One more thing that I want to add: please stay at home. Please stay safe. Stay online with the testbook.com. And my dear, one more thing: if you are new to this channel, then do hit like, share, subscribe the session as well as channel. My dear, channel को subscribe जरूर करें and share the link of this channel with your friends and family members as well. So those who are looking for the previous year questions, especially third year students, इतना basic कोई नहीं करवा रहा. So that's why I told you that if you want very basic thing, I will explain each and everything. Even you can ask the doubts, I will answer each and every doubt. Okay. So guys, if you want to learn more, then you have to share the link of this video more and more in your social media groups. Okay. So guys, take care and do hit like, share, and subscribe the channel. One more again, I'll request. And thank you so much for listening me patiently and attending the session. So guys, take care. Bye bye. We'll see you tomorrow.